Good day, everyone. We are Group 4, and we're here to present the application of LOMI in different kinds of circuits. So first, I am JC Cortez, and my group mates are Janice Dylan Katapang and Aaron DeGuzman. So, Janice will explain about how the LOMI functions.
So for the Lomi IC to function, we are first need to understand that if the XY for this input is 0, 0, all of the gates from the Lomi are inverters. And if the input for XY is 0, 1, all of the it is all N gates, and for XY for to be 1, 0, it is all 4 gates. So for an example, if this input is 0, 0, then having 1 for B is gonna turn the gate 1 to 1. And if the input is 0, 1, all gate all input should be turned on to for the gate to light on. And lastly, for 1, 0, only it only need one input to to, to be enabled.
So, after determining the function of Lomi, so for first we are going to apply it to the half adder. So what is a half adder? Half adder is a combinational arithmetic circuit that adds two numbers and produces a sum and a carry bit. So as you can see here in this circuit, in the first uh actually this is a circuit that is given by the professor, and we've figured out the IC that she views, which is the 4704. It is a NOT gate. It is a NOT. It is an IC that contains NOT gates, and a 7408, which contains AND gates, and 7432, which contains OR gates. So as you can see in the first half of the circuit, it is a half adder that consists of ICs, and then for the second half, it cons it is a circuit that consists of the LOMI ICs. So if you're going to click one of the inputs, you'll be able to see that the output, which is the sum from both the LOMI and the original circuit, are the same. So next, for the full adder. So for the full adder, it is defined as a logical circuit that performs an additional operation on three 1-bit binary numbers. A full adder produces a sum of three inputs and a carry value. So as you can see on the first half of the circuit, we've also applied the IC. It contains the NOT and OR gate, and as well as the AND gate. And we have the sum and the carry outputs. And on the bottom half, we have applied the LOMI. And if we are going to click one of the inputs, as we can see, the part where the sum of the output have the same for the both of of the circuit. So next, for the half subtractor.
For the half subtractor, we are here presented by a circuit that consists of the subtractor. A half subtractor is like a half adder, but it subtracts. And by clicking one of the input, and it lights up for X, and if we click the second input, all of the output lights up. But if we both click the inputs, it will not light up. That's it. That is the purpose of a half subtractor. So for the full subtractor, we are it is the tool subtractor that has a lot of complex gates, and by lighting one of the input, all of the outputs are lights up. For the B, one of lights up, and for the C, all of the lights up. But if we click light all of the inputs, only one will light up. So for the 4-bit encoder,
The 4-bit encoder is more commonly called as a binary encoder that takes all its data inputs one at a time and then converts them into a single encoded output. So we can say that a binary encoder is a multi-input combinational logic circuit that converts the logic level 1 data at the inputs into an equivalent binary code at its output. So for our 4-bit encoder, we have used the 7404 IC and 7408 and 7432 IC. Uh, Next na. So for our 4-bit decoder, um, it is a combinational logic circuit that is used to change the code into a set of signals. It is the reverse process of an encoder. A decoder circuit takes multiple inputs and gives multiple outputs. A decoder circuit takes binary data of n input into 2 raised to n unique output. In addition to input pins, the decoder has enable pin. This enables the pin when negated to make the circuit inactive. So for this circuit, we only use the 7404 and 7408 IC. Tapos, ano na okay na yun.
So for the 4-bit multiplexer, um, so the 4-bit multiplexer is defined as MUX or MPX. It is a combinational logic circuit designed to switch one several input lines through a single common output line by the application of a control signal. So as we can see here in the circuit, in the first half of the circuit, we have used an an IC of 4704, a 4708, and also a 4732. And then for the second half, we have applied the concept of LOMI. And as we can see, we have on the on the inputs, we have four input and one output for each of the circuit application. So if we're going to click one of the inputs, another one.
Natin.
Yeah. So that's how, as you can see, both of the circuits have the same output. So for the 4-bit demos,
For the 4-bit demultiplexer, it takes one single input data line and then switches it to any one of a number of individual output lines one at a time. The demox converts a serial data signal at the input to a parallel data at its output lines. So for this circuit, we have used the 7404 and 7408 IC. And for the 4-bit comparator, so a 4-bit comparator is a hardware electronic device that takes two numbers as input in binary form and determines whether one number is greater than or less than or equal to the other number. Uh, Comparators are used in CPUs or MCUs. So for this circuit, we have used the 7404 and 7408 and 7432 32 IC. Okay.
So, for the 2-bit decoder, so a binary decoder as defined is a combination of logic circuit that converts binary information from the n-encoded inputs to a maximum 2 raised to n unique outputs. So, as we can see here, there are only two IC circuit, which is the 7404 and the 7408. And we have four outputs. And for the lower half of the circuit, we have applied the low-mi version of that circuit. So if we're going to click an input, as we can see, both of the outputs for the low-mi and the application of the IC are the same.
So for the 2-bit encoder, an encoder is a combinational circuit that performs the reverse operation of a decoder. So by clicking one of the input, both the IC circuit from the LOMI and from the 7404, 7408, and 7432 have the same input, and by clicking the second input, they still have the same output, and by clicking the two inputs, they still have the same output. So for the 2-bit comparator, it is it is defined here that if we click A, and therefore it is A is greater than B. Then if we click B, then B is greater than A. So by that logic, by clicking one of the input, it lights up the output lights up. So for the 2-bit multiplexer, it is also known as a data selector, and that selects between several analog or digital signals. So the output is S prime A plus SB. So the selector here select that if B is B is lighting, then the output should also light. And if S is equals 0, then the A1 is the will light up the outputs.
So, as for the last part, demultiplexer is defined as it takes one signal input data line, then switches it to any one of a number of individual output lines one at a time. So, as we can see here, we have applied again an IC of 7404, 74 and 7408. And then for the lower half, we have applied the concept of LOMI for which is the equivalent of the 7404 and the 7408. And if you're going to click um one of the inputs, as we can see, the output for the LOMI and the IC are the same. So, as a conclusion, we can see that we have applied LOMI to different to the different types of the circuits which are required: the half adder, the full adder, the half subtractor, the full subtractor, the 4-bit encoder, the 4-bit decoder, the 4-bit multiplexer, the 4-bit demux, the 4-bit comparator, the 2-bit decoder and encoder, and then the 2-bit comparator, and the 2-bit MUX, and the 2-bit demux. So that's it for our presentation. Thank you.